This is a video walkthrough for practice 7a. In number 1, we're asked to explain the mistake and correct the solution. In our first step here, they've added 1 to both sides, which is correct, but the completing of the square is wrong. So let's draw a picture to illustrate why. So the first two terms are x squared and 2x. When we divide that into 2 equal pieces, that's 1x a piece. So that's x plus 1 times x plus 1. And when we complete the square, that's 1 times 1 is 1. So to complete the solution correctly, we have x squared plus 2x plus blank equals 1 plus blank. Completing the square correctly, we have 1 in each blank. So that means that x plus 1 squared is equal to 2. And that means that x plus 1 is equal to positive or negative square root of 2. And adding negative 1 to both sides, negative 1 plus or minus the square root of 2 is the correct solution. All right, in 2 through 9, we're solving using the square root property, or really just basically inverse operations. So if we think about the operations in number 2, squaring on x happens first and then subtracting 1. In 2, if we look at the order of operations, squaring happens before subtracting. So when we undo the operations, we need to undo in reverse order. So add 1 first, and then undo the squaring. And if x squared is equal to the square root of 18, if x squared is equal to 18, then x is plus or minus the square root of 18. We can simplify that answer, and that will be simplified to 3 times the square root of 2. In number 3, we can observe what the order of operations is here. Exponentiation happens first, followed by the multiplication by 2. That means the multiplication needs to be the first to go away. So divide by 2, and we get n squared is equal to 25. And then n is equal to plus or minus the square root of 25. So n is positive or negative 5. 2 solutions. In number 4, u squared plus 9 is equal to 0. Squaring happens first, followed by addition. So the addition needs to be the first to go away. So subtract 9 from both sides. Now undo the squaring. So if u squared is equal to 9, then u is equal to the positive or negative square root of negative 9. And the square root of negative 9 is 3 times I. So u is equal to positive or negative 3i. There's no real solution to this equation, but there is an imaginary solution. In number 5, looking at the order of operations here, we have negative 2 times k squared is equal to 48. So exponentiation happens before multiplication. That means the multiplication needs to be undone first. Dividing both sides by negative 2, we get k squared is equal to negative 24. So k is equal to positive or negative the square root of negative 24. That's going to be an imaginary solution, but we also need to be able to simplify that root. 4 is a perfect square, so 2i times the square root of 6. So positive or negative 2i times the square root of 6 are the 2 solutions. In 6, we have w plus 5 squared is equal to 9. If we look at the order of operations here, parentheses happen first and then squaring. So that means the squaring needs to be first to be undone. So if w plus 5 squared is equal to 9, that means that w is equal to the positive or negative square root of 9. It's best in these situations to divide this into 2 equations. Either w plus 5 is equal to the positive square root of 9, or w plus 5 is equal to the negative square root of 9. Subtracting 5 and subtracting 5, we get 2 solutions of negative 8 and negative 2. In number 7, again, parentheses happen before exponents, and so the exponent needs to be the first one to be undone. So if y minus 5 squared is equal to 5, y minus 7 is equal to the square root of 5 or the negative square root of 5. And so I can add 7 to both sides, and we get 7 plus or minus the square root of 5. In 8, c plus 3 squared is equal to negative 25. We need to undo that squaring first. So c plus 3 is equal to the positive or negative square root of negative 25. And that means that c plus 3 is equal to plus or minus 5i. Adding negative 3 to both sides, we get a solution in the form negative 3 plus or minus 5i. In 9, we're going to need to undo squaring first and then undo the operations inside the parentheses. So undoing the squaring, 2x minus 3 is positive or negative square root of 8. And that means that 2x minus 3 is equal to positive or negative 2 times the square root of 2 when we simplify. We can next add 3 to both sides, 3 plus or minus 2 times the square root of 2, and then divide by 2. 3 plus or minus 2 times the square root of 2 divided by 2. It can be tempting to simplify by reducing the factors of 2, but we can't do that unless we separate the terms because the 3 is not divisible by 2. In 10 through 13, we're practicing completing the square, so I'm going to draw a picture. And the first two terms in our trinomial are x squared minus 10x, and so the 10x will be divided into two equal pieces to represent the inner and the outer products. And x squared is x times x. That makes the other term in each binomial minus 5. And then completing the square plus 25. So x squared minus 10x plus 25 completes the square, and that factors into x minus 5 squared. In 11, we can also draw a picture. N squared, and then 12n divides into two equal pieces, 6n and 6n. That makes the factors of the trinomial n plus 6 and n plus 6, which means that completing the square involves adding 36. And now this factors into n plus 6 squared. In number 12, a squared minus 3a plus blank. First term is a squared, and dividing that minus 3a into two equal pieces, that's minus 3 halves a in each box, making the binomials a minus 3 halves and a minus 3 halves. Negative 3 halves times negative 3 halves is positive 9 quarters, so adding 9 quarters completes the square, and this factors to a minus 3 halves squared. For the next trinomial, y squared is the first term, and dividing 6/7 into two equal pieces, that's 3/7 y in each box. And so our factors are y plus 3/7 and y plus 3/7. So 9/49 completes the square. So if we add 9/49, then this will factor into y plus 3/7 squared. In 14 through 25, we're asked to solve each quadratic equation by completing the square. So I'm going to move my constant term to the right side of the equation and insert a plus blank. It's important, of course, first to verify that the coefficient of x squared is 1. This will not work unless the coefficient is equal to 1. So now I'm going to draw my complete the square picture. X squared plus 4x plus 4x, which means that we complete the square with a 16. And that gives us x plus 4 squared is equal to 11, negative 5 plus 16. That means that x plus 4 must be positive or negative square root of 11. And adding negative 4 to both sides, the solutions are negative 4 plus the square root of 7 and negative 4 minus the square root of 11. In 15, we again have a equal to 1, so that's good. So all we need to do is move that 44 to the other side of the equation and complete the square. N squared minus 10n minus 10n. And that means that 100 completes the square. So now we have n minus 10 squared is equal to 144. If n minus 10 squared is 144, then n minus 10 is positive or negative 12. And so if we add 10, we get 10 plus or minus 12. Do not leave your final answer this way. 10 and 12 can be combined. 10 plus 12 is 22. 10 minus 12 is negative 2. So negative 2 and positive 22 are both solutions. In 16, we need to make the coefficient of y squared equal to 1, so I'm going to multiply all terms by 2. And then I'm going to insert a plus blank on both sides. Let's draw a picture for complete the square. We have y squared plus 1y plus 1y, and that gives us factors of y plus 1, which means we can complete the square with 1. And that gives us y plus 1 squared is equal to 7. And if y plus 1 squared is equal to 7, then y is equal to the positive or negative square root of 7. Subtracting 1 or adding negative 1 to both sides, negative 1 plus or minus the square root of 7. In 17, the coefficient of k squared is 1, so I'm just going to isolate the k squared minus 4k, put a plus blank on both sides, and we're going to add that negative 5 to both sides to move the constant term to the other side. Let's draw a picture for complete the square. K squared minus 2k minus 2k, and completing the square, we have a 4, which gives us the factors of k minus 2 squared is equal to negative 5 plus 4 is negative 1. If k minus 2 squared is negative 1, that means that k minus 2 is the positive or negative square root of negative 1. Let's simplify that. That's positive or negative I, adding 2 to both sides. 2 plus or minus I are two solutions, 2 plus I and 2 minus I. Number 18, since c squared has a coefficient of 1, we don't need to adjust. All we need to do is add a plus blank to both sides. And now let's draw a picture for complete the square. C squared minus 1c minus 1c. This is factors of c minus 1, and positive 1 completes the square. And that's going to give us c minus 1 squared is equal to 2. And if c minus 1 squared is equal to 2, then c minus 1 is either the positive or negative square root of 2. Adding 1, 1 plus the square root of 2, 1 minus the square root of 2, those are our two solutions. In number 19, coefficient of the squared term is 1 already, so I'll leave that and add negative 2 to both sides and insert a plus blank. A squared, dividing 5a into 2 equal pieces, that's 5 halves a plus 5 halves, a plus 5 halves, and that gives us 25 quarters to complete the square. So the trinomial factors to a plus 5 halves squared, and negative 2 plus 25 quarters is negative 8 quarters plus 25 quarters. So a plus 5 halves squared is equal to 17 quarters. And if a plus 5 halves squared is 17 quarters, then a plus 5 halves is equal to positive or negative square root of 17 over the square root of 4, which is 2. And if I add negative 5 halves to both sides, we can combine the fractions together. Negative 5 plus or minus the square root of 17, all divided by 2. In number 20, I'm going to begin by dividing each term by 3. And then moving the 1/3 to the right side of the equation, and at the same time I'm going to insert a plus blank. Let's draw a picture for complete the square. K squared plus, and that 4/3 k divides into two equal pieces, each with 2/3 k. So the factors of the trinomial are k plus 2/3 and k plus 2/3. 4/9 completes the square. So on the left side we have k plus 2/3 squared, and on the right side we have 1/3 plus 4/9. We need a common denominator, and that will be 3/9 plus 4/9, which is 7/9. And if k plus 2/3 squared is 7/9, then k plus 2/3 is positive or negative square root of 7 over square root of 9, which is 3. If we add negative 2/3 to both sides, we can combine. So we get negative 2 plus or minus the square root of 7 divided by 3. In 21, we can begin by dividing all terms by 2. And now I'm going to isolate the variable terms on one side with a plus blank, add 5 halves to the other side, and insert plus blank there as well. Let's draw or complete the squared picture. U squared minus 3 halves u divides into two equal pieces, each of negative 3/4 u, which gives us factors of u minus 3/4 and u minus 3/4. 9/16 completes the square. And so u minus 3/4 squared is equal to, and on the right side we're going to need a common denominator. Let's multiply 5 halves by 8 over 8. That will be 40 over 16 plus 9 over 16, which is 49/16. And if u minus 3/4 is equal to, squared is equal to 49/16, that means that u minus 3/4 is plus or minus the square root of 49, which is 7, over the square root of 16, which is 4. So now what we can do is we can add that 3/4 to both sides, and we can combine the fractions here. So we've got positive 3 plus or minus square root of 7 all over 4. And I wrote square root of 7, but what I meant was 7. Don't leave your answer like that. We can actually do the combination of like terms here. 3 plus the square root of 7 is 10. 10/4 is 5 halves. 3 minus the square root of 7 is negative 4. Negative 4/4 is negative 1, so we get two solutions, negative 1 and 5 halves. In 22, the coefficient of x squared is 1, so we're going to leave our variable terms on one side, add negative 28 to both sides, and now we have plus blank on both sides. Let's draw or complete the square picture. X squared plus 10x is 5x and 5x. So our factors are x plus 5 and x plus 5. 25 completes the square. So now we have x plus 5 squared is equal to negative 28 plus 25, which is negative 3. If x plus 5 squared is negative 3, then x plus 5 is plus or minus the square root of negative 3, which is an imaginary number. Let's simplify it first. That's plus or minus I times the square root of 3. Adding negative 5 to both sides. Negative 5 plus or minus I times the square root of 3 are our two solutions. In number 23, m squared minus 4m 14m plus 4 is equal to 0. Since the squared term already has a coefficient of 1, all we need to do is add that negative 4 to both sides and insert plus blanks. Drawing the complete the square picture, m squared minus 7m minus 7m. The two factors are m minus 7 and m minus 7. 49 completes the square. So factoring m minus 7 squared is equal to 45. If m minus 7 squared is equal to 45, then m minus 7 is the square root of 45, or the opposite of the square root of 45. Let's simplify that. That's plus or minus 3 times the square root of 5. Adding 7 plus or minus 3 times the square root of 5 are our two solutions. In 24, the terms really aren't where we want them, but let's start by dividing all terms by 4. That way the k squared will have a coefficient of 1. 6 divided by 4 is 3 halves, so I'm going to write 3 halves k there. Now we're going to bring the 3 halves k to the left side of the equation by subtracting it, insert our plus blank, and bring the 1/4 to the right side by adding it, and plus blank over there as well. Alright, let's complete the square picture. K squared. And then we've got to divide 3 halves in half, so that's minus 3/4 k in each blank. Factors are k minus 3/4 and k minus 3/4. 9/16 completes the square. So the trinomial factors 2k minus 3/4 squared, and then now we need a common denominator. So we'll have 4/16 plus 9/16, which is 13/16. And if k minus 3/4 squared is 13/16, then k minus 3/4 is plus or minus the square root of 13 over the square root of 16, which is 4. And now adding 3/4 to both sides, 3 plus or minus the square root of 13 over 4. In 25, we have a coefficient that's imaginary. Never fear, it'll still work. Okay, so x squared minus 6ix plus blank is equal to 5 plus blank. So now, I'm going to draw my complete the square picture, x squared, and half of negative 6ix is negative 3ix. And that means that our factors are x minus 3i and x minus 3i, which means that we complete the square with a 9i squared. Well, 9i squared is actually negative 9. So for once here, we're going to put a negative number in that plus blank. So x squared minus 6ix minus 9 factors into x minus 3i squared, and 5 plus negative 9 is negative 4. And if x minus 3i squared is negative 4, then x minus 3i, don't need parentheses anymore, will be equal to plus or minus the square root of negative 4, which is plus or minus 2i. So adding 3i to both sides, we have 3i plus or minus 2i. That means that one of the solutions is 3i minus 2i, which is I, and the other is 3i plus 2i, which is 5i. So we get two imaginary solutions. In this case, they're not conjugates because we have imaginary coefficients here. In 26 through 27, we're going to write a quadratic equation to represent the problem situation and then solve it. In 26, we have a right triangle. So I'm going to draw a picture of a right triangle. And the hypotenuse is 3 feet longer than twice the length of its shorter leg. So let's call the length of the shorter leg x. And the hypotenuse is 3 feet longer than twice that length. So 2 times that length is 2x. 3 feet longer, we can add 3 to that. If the longer leg is actually 12 feet long, then we're going to write an equation to solve. The sides of a triangle work in the Pythagorean theorem, so one leg squared plus the second leg squared should equal the hypotenuse squared. So x squared plus 144 equals 4x squared plus 12x plus 9, doing the squaring. And now we're going to want to have all of our terms on one side. So I'll subtract x squared. Also, we can subtract 144, which gives us minus 135. Before we get started with factoring to solve this, let's actually observe that all the coefficients here are divisible by 3. So this will give us x squared plus 4x minus 45 is equal to 0, which will be easier to factor. The factors are x plus 9 and x minus 5. So that'll give us two solutions. X is equal to negative 9. Second solution, x is equal to 5. In the context of a geometry problem where side length is represented, negative 9 doesn't make sense. So 5 is a valid solution. It is the length of the shortest side of this triangle, so 5 feet is the short leg. And the hypotenuse is 2 times 5 plus 3, which is 13 feet. So those are the other two sides that are requested. In 27, we have a height function. The height in feet of a ball thrown in the air is given by the equation h of t is equal to negative 16t squared plus 24t. At what times, notice there are two solutions here, is the ball 8 feet in the air? So if you want, you can just scratch out the of t and just treat it as h as a separate variable. H represents height. And so we want to know when is the height 8. So I'm going to replace h with 8 and then solve for t. Let's observe here that everyone is divisible by 8. So let's just get that over with. So dividing by 8, 1 is equal to negative 2t squared plus 3t. And we can add 2t squared and subtract 3t from both sides of the equation, which will give us our terms on the left side, and it'll also give us a t squared term with a positive coefficient, which makes factoring easier. Now we can factor 2t minus 1 and 2t minus 1 and t minus 1. And if 2t minus 1 is equal to 0, then t is equal to a half. And if t minus 1 is equal to 0, then t is equal to 1. And so the ball is 8 feet in the air, 1/2 second, and 1 second after being thrown.